presentation for today is called The Invisible Nano World. Nanotechnology that performs nano-level development is the technology that supports our 21st century advancements. Research is being conducted across the world in fields that include medicine, the environment, and energy. And now we would like to introduce our ramen nano mixer and ramen stirrer that enable excellent nano mixing. The ramen nano mixer is a dream machine that realizes uniform and stable quality by nanoizing substances within 30 seconds. The ramen stirrer is a simple structured stirring blade that delivers outstanding stirring performance. Here we have completed the ramen nano mixer and ramen stirrer through 10 years of research and development in conjunction with academia and succeeded in their practical application. Regarding the epoch-making technological application, we have applied for and obtained more than 30 national and international patents. In August 2013, our joint research team, in conjunction with academia, applied for a patent related to a water-mixed fuel-generating apparatus requiring no additives. The ramen nano mixer is a static mixer, not having a drive section. An important feature is the ability to mix and disperse various substances uniformly and stably by passing them through the honeycomb unit under pressure. Nanox has developed equipment using the ramen nano mixer as a core device in each field of application. Now we would like to introduce the features and uses of respective products. The NanoQuick is a compact nano-mixing device that we developed for research institutions. Equipped with the ramen nano mixer and ramen stirrer, it is suitable for gas-liquid and liquid-liquid mixing. For gas-liquid mixing, it generates ultra-fine bubbles at a high density. Ultra-fine bubbles are generally referred to in nanometers, thousands of parts of micrometers. When becoming extremely small, bubbles show a drastic change in properties. Application of this unique nature offers promise across many fields. Now let's see how the NanoQuick generates ultra-fine bubbles. Water and air are circulated while being passed through the ramen nano mixer under a pressure of 1 megapascal. In order to avoid a rise in treated water temperature by pump and shear, the treated water temperature is controlled by watering. Normally, the door is closed and the circulation line is submerged in water for cooling. Use of an optional thermal chiller enables additional cooling. This water, having undergone a 10-minute circulating operation, contains ultrafine bubbles. The water appears as clear to the naked eye because the generated bubbles are ultrafine. We measure ultrafine bubbles with a nanoparticle analyzer manufactured by Nanosite. At nano levels, substances make submicroscopic movements called Brownian motion. On the computer screen of the analyzer, the state of movements can be observed in real time. Because the speed of the Brownian motion correlates with the particle size, a particle size distribution graph with density can be obtained by measuring the movement pattern. These are the results of measurement with the analyzer. The average particle diameter is 107 nanometers, and the bubble density is 875 million per milliliter. The particle size distribution graph also shows high uniformity as it is in an acute angle mountain shape with one peak. The NanoQuick generates ultra-fine bubbles by refining bubbles with continuous high shear fields in the ramen nano mixer. It is characterized by a high bubble density compared with other generating methods. To develop a gas-liquid reaction efficiently, it is required that the gas-liquid contact area is large. The efficiency of the gas-liquid reaction is remarkably improved by ultra-fining the gas. The next case shows liquid-liquid mixed dispersion. Here you see comparative experiments using water and oil, the mixing of which is very difficult. First, water and cooking oil are mixed by using a common mixer. Water and oil separate as soon as they are poured in. The mixer is turned on to mix them for 3 minutes. Next, they are mixed by using the NanoQuick. Water and oil separate as soon as they are poured in. When they are stirred by the Raman stirrer, they are emulsified instantaneously. Then, the particles are further refined in size while passing through the Raman nano mixer under pressure. In this way, mixing is carried out for 3 minutes. This is a comparison in mixed state of water and oil. It can be seen that the state brought about by using the NanoQuick is definitely a thicker, milky white. These are microscope photographs magnified 1,600 times in comparison. It can be seen that, with the use of the NanoQuick, cooking oil, which is a hard dispersoid, is ultra-fine and dispersed uniformly. For stable mixed dispersion of water and oil, emulsifiers have been indispensable so far, but use of the Raman nano mixer enables ultrafine uniform dispersion instantaneously, being nanoized uniformly and stably without using emulsifiers. An even more important feature is the number of circulations. This data is about nanoization of a 10% liquid paraffin aqueous solution. The refinement of mixture advances according to the number of circulations through the honeycomb unit. The larger the number of circulations, the finer the substances become. A dressing is nanoized by using this technology. Under normal conditions, it separates immediately. However, we have confirmed that when the Raman nanomixer is used, even if the oil and fat content is 40%, it is easily mixed by simple gentle shaking, and it can keep an unseparated state for about 20 minutes. The compact NanoQuick, having outstanding gas-liquid and liquid-liquid mixing performance, offers promise in application for research and development in various fields. Today, it is adopted for soil purification, water purification, and other research. The nanofresher is an ultra-fine bubble generator that controls the concentration of oxygen dissolved in water from under 1 mg per liter to 48 mg per liter. Our lineup offers 4 types of equipment according to the amount of water treated, between 100 liters and 5,000 liters. Now let's see how the nanofresher generates high oxygen water containing ultra-fine bubbles. Water and oxygen are simultaneously passed through the nanofresher NFWP 0.4 under pressure while connected with an oxygen generator, and circulation is performed for 40 minutes. At that time, the dissolved oxygen concentration is 51.76 milligrams per liter, and the water temperature is 1 degree Celsius. While there is normally a limit of 40 milligrams per liter, even with the use of the most recent facilities, it can be easily exceeded by using the Raman nano mixer. The high oxygen ultra-fine bubble technology using nanofresher promises application in environmental fields such as agriculture, fisheries, and soil and water purification. Now we would like to introduce an example of an application using the nanofresher for onshore fish farming and the effects of its installation. Icarus in Onomichi City, Hiroshima Prefecture. Icarus has installed the nanofresher for oxygen supply to their closed circulation filtration type culture system, aiming at cost reductions and improvements in profitability related to onshore fish farming. As for this system, Nanox and Icarus have applied for a joint patent. Please look at the system flowchart. The seawater used in the closed circulation filtration type is subjected to cycle filtration and reused. The breeding water, having passed through the nanofresher, is high oxygen water containing ultrafine bubbles, the dissolved oxygen concentration of which is 20 milligrams per liter. Oxygen supply in one location can control the dissolved oxygen of the entire system, around 10 milligrams per liter. Therefore, there is no need for an oxygen supply device for each breeding tank. Generally, fish breeding under a high oxygen environment is associated with the risk of gas bubble disease. But ultrafine bubbles provide a safe breeding environment that does not cause gas bubble disease. Not only that, but there are even more outstanding results. Please look at this data showing the number of common bacteria in breeding water containing ultrafine bubbles. It can be seen that the number of common bacteria is 32 per milliliter, which is extremely small. From the fact that the number of common bacteria in ordinary seawater is 10 raised to the 5th power to 10 raised to the 6th power per milliliter, it is clear that ultrafine bubbles have an astonishing sterilizing property. Also, due to the cleaning effect of ultrafine bubbles, dirt hardly adheres to breeding tanks, waterways, and piping facilities. This can decrease the number of times of extensive washing of breeding tanks and reduce stress on fish, number of workers, and so on. What is more surprising is the growth-promoting effect. Several months can be shortened until growth and size suitable for shipment. Substantial economic effects can be expected by productivity improvement. Practical tests for greater efficiency of kuruma prawn farming by using the nanofresher are in the works at the Faculty of Fisheries of Kagoshima University. If prawn farming data is established, worldwide demand expansion launched from Asia can be expected. Next, let's see how the nanofresher generates low oxygen water containing ultrafine bubbles. 1,000 liters of water, the dissolved oxygen concentration of which is under 1 milligram per liter, is generated in 40 minutes by using the nanofresher NFWP 2.2. The dissolved oxygen concentration of pre-treatment water is 8.4 milligrams per liter. Water and nitrogen are simultaneously passed through the nanofresher under pressure, as it is connected with a nitrogen generator, and circulation is performed for 40 minutes. Ultrafine nitrogen bubbles are generated in water, and dissolved oxygen is diffused in the atmosphere. Use of ultrafine bubbles dramatically enhances the deoxidation efficiency and enables long-time maintenance of low oxygen state. The dissolved oxygen concentration after 40 minutes of circulation shows a value of under 1 milligram per liter. Low oxygen water containing ultrafine bubbles, showing the effects of antioxidation and suppression of growth of aerobic bacteria, is used for keeping the freshness of seafood. As a typical example, it is used for seawater and fish tanks of inshore tuna longline fishing boats. On inshore tuna longline fishing boats, fish caught during an operating period of 21 to 28 days are kept in seawater between 1 to -2 degrees Celsius, called water ice, and are landed in a raw state. Tuna can be landed in a very fresh condition by making the seawater low oxygen water containing ultrafine bubbles. Tuna tuna with freshness kept in this way are highly valued on the market and traded at high prices. Since dirt in fish tanks is less than that of in conventional tanks, significant economic effects have been brought about, allowing for easier cleaning and lowering in costs to keep freshness. Now we would like to introduce a fish market case. When seafood is traded, product prices are extremely unstable due to such factors as the delivered amount and the balance between supply and demand. Great economic effects can be expected by keeping freshness through the use of the nanofresher. For example, a substantial profit can be made by making shipping adjustments, such that products are purchased when the catch amount is large and the price is low, and sold when the price is high, as the freshness is maintained. Also, significant economic effects are produced as the distribution of fish varieties, which would normally be marketed only locally because of quick deterioration of freshness, can be expanded to consuming markets, such as the Tokyo metropolitan area, by keeping freshness with the nanofresher. Applications related to the nanofresher in the fishing industry are increasingly expected in the future. We also think that it can be used in agricultural, environmental, and other fields as unprecedented large-capacity processing equipment. The ultrafine bubble cold saltwater processing apparatus, Shinsen Tamotsukun, is a device we have developed for supermarkets and fish stores for the purpose of keeping the freshness of fish. Seafood freshness is kept by washing it with cold salt water containing ultrafine bubbles. It can be used for processes as simple as pickling seafood in cold salt water containing ultrafine bubbles generated by Shinsen Tamotsukun, the salt concentration of which is 2% for 3 to 10 minutes. Here are comparative photographs of farmed yellowtail with freshness kept by Shinsen Tamotsukun and unprocessed yellowtail 24 hours after cutting. The discoloration of the dark-colored meat is inhibited by use of Shinsen Tamotsukun. Also, can you see the tension of the meat and the angular cut ends? Here are similar comparisons made with Argentinian pink shrimp. While the unprocessed shrimp is black at the head, that processed by using Shinsen Tamotsukun has no change in color even after 24 hours. Product markdowns as a result of downgrading and disposal loss can be reduced by keeping the freshness of products displayed at counters, allowing for greater efficiency in store management. Also, products can be stocked with freshness kept when the delivered amount is small due to storms or lengthy holidays. Therefore, products can be stably provided to customers without missing sales opportunities. As of October 2014, it has been installed and well received in dozens of stores. Here we have a video of flames in the combustion chamber of a 55-ton water tube boiler manufactured by a manufacturer. The fuel used is a water-mixed fuel made by mixing water and heavy oil with the Raman nano mixer. For the mixed fuel of water and heavy oil, conventionally, additives would normally be used. An epoch-making manufacturing method not using additives was developed through the use of the Raman nano mixer that nano-mixes different liquids. Achieving recognition of this technology, we conducted joint research with the National Fisheries University and further announced astonishing results. In experimental research of a marine diesel engine using 30% water-added heavy oil A, we confirmed simultaneous reduction of fuel consumption by approximately 5%, NOx by approximately 35%, and PM by approximately 60%. Having been officially announced by the Japan Institute of Marine Engineering, our research results have attracted attention as a technology to reduce fuel consumption and purify emissions. We sell this manufacturing line and control packaged under the name of the Ecomizer. It is well known that royal jelly is a high molecular substance in general. This royal jelly is ultra-refined by using the Raman Nano Mixer. Royal jelly is set to the Raman Nano Mixer and sheared under pressure of 1 megapascal. Then, as you can see, the viscous royal jelly is ultra-refined instantaneously. What is poured in a cup is a small amount of ultra-fine royal jelly that was dissolved in water for 90 days. In spite of the passage of 3 months, the dispersed state of the royal jelly is unchanged. This ultra-refining technology is expected to be applied to various products because highly functional substances, having been hard to be absorbed into the body, can be raised in absorption rate, and their uniform and stable dispersed state can be maintained for a long time without additives. The next experiment is on the refinement of solids that is believed to be difficult. Here you can see how Mosoku seaweed is continuously refined and extracted in high concentration efficiently. Mosoku seaweed, cut to some extent, is tossed in the Raman Nano Mixer as it is. An important feature is the continuous refinement and extraction. It has been said that uniform refinement of solids is difficult. However, a uniformly nanoized Mosoku seaweed extraction liquid can be made by passing through the Raman Nano Mixer several times using the technology of continuous refinement and extraction. The original fiber, pigment, etc. of the material still remain. Because the extract is nanoized, it quickly scatters in water, and also the rate of absorption into the body rises. Generally, chemical treatment is provided for extraction. However, the use of the technology of continuous refinement and extraction enables component extraction as the original fiber, pigment, etc. of the material remain because it is sheared physically. Moreover, efficient extraction can be performed by simple operation. Its application to a wide variety of products, such as supplements and cosmetics, can be expected. Next, we explain the excellent results in gas-liquid mixing by using the Raman Nano Mixer. Here's a transition table of the carbonic acid concentration in the carbonated water containing ultrafine bubbles made by refining and mixing carbon dioxide in water. Kept open to the atmosphere, the carbonic acid concentration can be kept at 1000 ppm or more even 6 days after generation. Now we would like to introduce a bath using this technology. It has been confirmed that ultrafine bubbles have the effect of entering deeply into pores and absorbing and removing dirt from them. Also, energy generated when ultrafine bubbles adhering to the body collapse has a massaging effect, helping recovery from fatigue and warming from the core of the body. A bath generating ultrafine bubbles can be widely expanded, not only for home use, but also to various medical facilities, aesthetics, and pet care. What we will introduce next is the development of numerous products taking advantage of the emulsifying ability, including body-friendly dressings and milky lotions in the food and cosmetic fields. Also, innovative water-mixed fuels can be manufactured by nanomixed dispersion of fuel oil and water. The manufacturing method has been patented. Because oil and oil, water base, and fine powder and liquid can be mixed and dispersed uniformly, supplements with a high rate of absorption and extremely fine paints and inks can be developed, and it can also be used in sauces. Uniform and stable shear ultrafining enables component extractions as the fiber and pigments in plants remain. There are increased expectations for the development of body-friendly supplements that are easily absorbed in the small intestine and skin-friendly cosmetics by refining. Application fields of the Raman Nano Mixer are diverse. Ceaselessly, we devote ourselves to practical use of each research subject, based on joint research with universities in every field of specialization. Next, we would like to introduce the ramen stirrer. This has a simple structured stirring apparatus in which the honeycomb unit is rotated at high speed, and liquids having different properties are mixed, stirred, and dispersed instantaneously, uniformly, and ultra-finely. Now you can see the liquid flow with the operating ramen stirrer shown by using colored water. When cooking oil is poured in the colored water, they separate clearly in 2 layers, as you can see. At the beginning, they are stirred by a low-speed rotation so that the liquid flow is easy to see. Can you see that the colored water in the lower layer is sucked from below the stirring plate by a centrifugal force and spouted out of the side of the stirring plate? Structurally, the ramen stirrer takes in the liquid from below the stirring plate and ultra-fines and disperses it in the stirring plate so that the liquid is circulated in the tank efficiently. When the rotation speed is raised, it is nanomixed, dispersed, and emulsified instantaneously. In the rotating unit, various reactions occur. These reactions make a complicated flow into circulation, so that different liquids can be ultrafined instantaneously and uniformly. It is characterized by simple operation and maintenance and very few problems. The ramen stirrer's excellent mixing, stirring, and dispersing functions can be used for various things. Also, it is available in various sizes according to usage, from stationary type to handy type. Now let's see how agricultural chemicals and water are mixed in a clear container in an easy-to-understand manner. It is understood that they are mixed, stirred, and dispersed instantaneously and uniformly. From the uniform data of agricultural chemicals, there is only a small difference between the upper and lower parts as a result of stirring with the ramen stirrer. Because of such uniform ultra-fining, efficient work and stable effects can be obtained. The application ranges of the ramen nanomixer and ramen stirrer are diverse. Simple and compact structure brings good working efficiency, and at the same time, it allows you to wash the machine body very easily. Humans face challenges 10 years and even 100 years into the future. It is our responsibility to the world and humanity to provide solutions to food, population, and energy challenges for succeeding generations. We believe that we can move toward a brighter future one step at a time through use of our technology across a wide range of fields. What was once thought unreachable in the nano world can now be attained with the ramen nano mixer. We look forward to your inquiries about sales of equipment incorporating the ramen nano mixer and ramen stirrer, and seek companies who intend to develop products with our technology applied.